is the problem of circle placement in a circle. So we do have n circles with known radius, and we want to put them inside a bigger circle with the minimum surface possible without overlapping each other. So we have to write down some mathematical equations that represents the condition described. So first of all, for each pair of I and j, we have to write down the distance between the centers of them, xi minus xj square plus yi minus yj square, bigger than ri plus rj square. So ri and rj here are the radius of the both circles. And also we want to make sure that each small circle is completely inside the bigger circle. So xi minus r, which is the center of the bigger circle, plus yi minus r square less than r minus ri square. Okay, so in this way we are making sure that all the circles are inside the bigger one without overlapping each other. So let's have a look at the Python code and see how it works. First of all, we have to import the required packages, pyomo.environ import asterisk everything, import matplotlib.pyplot as plt, and import numpy as np. Then let me run this tab, and then we have to define the optimization model. We name it model. Model is an abstract model, and model I is a set representing all the circles, and also set j is the alias of set I. We have parameter r, which is now here is the parameter, known parameter, and also we do have three variables, x and y and radius. Radius is the radius of the bigger circle. Okay, so the dimensions and the bounds of variables are defined here, just some big numbers to avoid plus minus infinity. And also we do need some equations representing the distance of each pair of circles. So I less than j returns this expression. So as I already explained, we just do not only say I'm not equal to j, because this way it will calculate I and j and I. So we are in this way we are avoiding unnecessary conditions. Else return constraint skip. So this means that, for example, if I and j are equal to each other, it's not needed to be considered in this constraint. Model.eq1 is defined over I and j. The rule that should be followed is rule eq1. And model eq2 is a constraint defined over I to make sure the circle is inside the bigger one. Rule eq2 is model x minus radius square plus model y minus model radius square, less than equal to model radius minus model dots ri square. And also we need an objective function which is the model radius here. So we can say that instead of calculating the surface of that circle, we can say, okay, minimize the radius of the bigger circle. That these should give you the same kind of results, and the sense is the minimization. Okay, so we need to read the input data. So here let me show you the required data. Just a second. Okay, so this is the required data for this problem. As you can see here that the parameters are running from 1 to 6, and the radius of each circle is already specified. Okay, so the model will read this stat file and feed it into the model. The results are obtained. Okay, let me run this tab, and also this one. The model is solved, and we can graphically see what's happening here. So you can see that the minimum radius of the bigger circle is this quantity. Okay, you can test it for the objective function pi r radius square, so to see it will give you the same results. Okay, the value of objective function is different obviously, but the decision variables will remain the same. Thank you very much.